A pressing problem facing the United States military today is extensive contamination caused by a toxic substance called PFAS. The substance can be found in industrial waste products, as well as in the AFFF firefighting foam that has been used since the 1970s to control aviation fires at military bases and civilian airports. PFAS has been discovered at numerous installations around the world, and Department of Defense leadership has committed to further studying the issue. At the U.S. Army Engineer Research and Development Center, experts are discovering and developing new ways to solve the problems caused by the contaminant. The ERDC recently hosted a workshop on a PFAS research collaboration that brought together representatives from ERDC, EPA, and industry.
We've been meeting with our colleagues in the Environmental Protection Agency and industry about a collaboration to address an emerging contaminant issue that is affecting us nationally on fluorinated chemicals that are used to combat fires like aviation fires. These chemicals oftentimes can have effects that we're not aware of when these products are first developed and generated, and they become emerging issues. And these chemicals ending up in groundwater, in drinking water, can create very serious health issues.
So PFAS is an acronym that we use, per and polyfluoroalkyl substances. It's a class of chemicals. Some of the chemicals have been used since the 1940s and 50s in the US, but the number of chemicals has grown dramatically, especially in recent years.
AFFF represents a significant environmental liability to DoD. It's impacted a number of DoD installations, and as a consequence, DoD has taken significant action to try to address and mitigate those impacts. While AFFF represents the primary use relating to DoD activities, it's important to recognize that PFAS has been used in a variety of industrial processes. We also have the potential implication of having to address the presence of PFAS in the environment through a variety of other sources, and as a consequence, we need to continue to develop and understand the potential risk associated with the presence of PFAS in the environment, and that's one of the things that ERDC has been working on. We need to understand not only the implications for the legacy issues associated with AFFF, but the subsequent replacement compounds that are going to be utilized moving into the future to fight fuel-based fires and ensure that we've got a compound that provides the same level of efficacy in terms of protecting our soldiers in fuel-based fire scenarios, as well as ensuring that we don't create future environmental liabilities.
A challenge as complex as PFAS requires an interdisciplinary approach. ERDC has the engineers and scientists to expertly tackle the issue through four main focus areas: sample analysis, transport monitoring, effects on people and wildlife, and contamination cleanup.
PFAS is a challenging analyte to detect. 70 parts per trillion is the current EPA advisory limit. If you want to put that into context, a paperclip on a 747 is in the parts per billion range. So we're looking at a factor of 10 to 100 times lower concentrations than that. Compounded the fact that most instrumentation that we're using has PFAS in it. It's a component of Teflon essentially. Anytime you look at something that's commonly available everywhere, the chance for contamination is pretty high. So we have a variety of high technology instruments that can detect PFAS in these complicated environments. And it takes a lot of training and some scientific acumen to be able to develop these methods to detect this challenging compound. And so our people that are working on this are world-renowned experts on analytical method development.
When we look at fate and transport with PFAS, they're very complicated for a couple of different reasons. One is that PFAS isn't just one thing. It's 3,000 plus chemicals. And then with each of those, we don't always know all of the chemical properties for them very well. That's something we are doing research on to figure out how do they stick to different soils.
So the zebrafish lab, we do a lot of predictive toxicology work. So we use the zebrafish to understand what chemicals do, both in the environment and also to human health, for example. So the zebrafish is a great model to understand the mode of action of those chemicals and mixtures. When you have one chemical and you want to understand the toxicity, the standard toxicity tests are very lengthy, they're extremely expensive. It can be millions of dollars and even billions, and takes years. So if you have 5,000 chemicals that you need to understand, there's no way you can do all that. It's impossible. There's no money, there's no time. So the zebrafish is a really good high throughput or medium throughput way to start identifying the toxicity of those chemicals.
This is the PETS, and it stands for the PFAS Effluent Treatment System. PETS is designed to treat small quantities of contaminated water, maybe on the order of 250,000 gallons all the way down to maybe just 500 gallons. We did some calculations based on a project that we're doing at Hurlburt Field in Florida, and we've estimated the cost to dispose of that water would be about $300,000. If we use the PETS and condense the contaminants down into a solid media, we can actually reduce the disposal cost to about $200. The PETS is a great platform to test out other technologies because it's a very flexible design. You can see that we have the media filters. We can put anything we want into them. We also have room on the PETS system to add additional unit processes. These could be different technologies like membrane treatment or biological treatment or other kinds of chemical treatment. That gives us the ability to try out different types of treatment technologies.
I think one of the unique benefits of being at ERDC for doing this work is that we have such a diversity of different chemicals and contaminants we've worked with in the past. So we have this real breadth of experience with new emerging contaminants. And then we also have worked in different environments. We've worked in groundwater, surface water, soils, air pollution. So we have that big picture, the whole thing. And then we have a big concentration of different people who can apply their skills to this, which is not something you find everywhere else. You might have one colleague who works in this area. Here, I have 20 colleagues or more that can all contribute to solving the problem.
We all have our individual strategies, and what we see is data gaps and how we could reduce uncertainty. And if we can work with partners, you can get more done for the same amount of money, and you can get more of a consensus.
I think this is one of the exciting aspects of working for an organization like ERDC, to be able to work with others and other organizations, both within government and outside of government, to address problems as well as to address opportunities that are relevant to us in the modern world.